Hello guys, welcome back to the channel Mathemagix JEE. So today we are going to discuss a second mock paper for upcoming JEE Main 2025 first attempt. In this mock paper, I have tried to keep more conceptual questions than the calculative ones. So most of the questions here will be based on some specific concept and there are hardly any calculations in any of the questions. You can attempt this mock paper in time bounded manner. I will link the mock paper in the description and then you can see the discussion. So let's proceed with our discussion. The first question here, it says let theta be the angle between the vectors alpha and beta, where alpha and beta are given, okay, and a, b, c are real numbers. Then we have to tell what value of theta is not possible. So here the first idea that strikes our mind whenever we see the word angle between the vectors is dot product. So we can say if theta is the angle between these two vectors, so cos of theta will be alpha dot beta divided by modulus of alpha times modulus of beta. Now alpha dot beta will be AB plus BC plus CA and divided by, now both of these modulus is equal to root under a square plus b square plus c square. So if we square this, it will become a square plus b square plus c square. So from here we get the value of cos theta. Now we have to check what values of theta are possible. Now a, b, c are real numbers. That means the range of this right hand side is fixed. How? You have to keep in mind that the quantity in the right hand side, that is AB plus BC plus CA divided by A square plus B square plus C square, the range of this when ABC are real numbers is closed interval minus half to 1. How can you prove this? You simply take two inequalities, that is A plus B plus C whole square is greater than equal to 0 and also a minus b whole square plus b minus c whole square plus c minus a whole square greater than equal to 0. From these two inequalities, you can find this range. Now, if we consider this range in this question, so cos theta must lie between minus half and 1. So, what will be the value of theta? Theta will lie in the range 0 to 2 pi by 3. This is the range of theta. So from the options, we can check that theta can take value pi by 4, which is in the range, and 2 pi by 4, which is pi by 2. So this is also in the range, but 3 pi by 4 is not in the range. So theta cannot take the value, will be option C, 3 pi by 4. So C is the correct option for this question. I hope you understood this question. Let us proceed. Here comes the second question. It says the value of this integral is what? Okay. So we have to solve this integral. Now, the first idea that strikes our mind is whenever we see a sin x plus b cos x type of expressions, we generally convert the whole expression in a single sine or single cosine. Here, I am going to convert it in a single sine function because for sine function, the limits are easier to handle. That means we can write this as, if we write this expression like this, so we multiply and divide by root under 13 square plus 3 root 3 whole square. So this will be root under 169 plus this will be 27. That means it will become 14. So if we multiply and divide by 14, this will be like this. And now inside this bracket, we can write this expression as this. If we consider cos theta, this will be automatically sin theta. So cos theta sin x plus sin theta cos x. So sin of theta plus x. That means we can write this as sine of x plus theta, where this theta is cos inverse 13 divided by 14. So if we substitute this in the given integral, it will become integral 0 to 4 pi log of modulus of 14 sine of x plus theta, then modulus close, then dx. So this will become integral. Now we can again substitute x plus theta equal to t. So dx will become dt. So this will be, the limit will get changed to theta to 4 pi plus theta. So theta to 4 pi plus theta log of, this will be modulus of 14 sine t then dt. Now we have to recall a very important property for definite integral, that is integral a to a plus nt f of x dx is equal to n times 0 to t f of x dx, where this capital T is the period of this function. We have to apply this property here. So here theta plays the role of this a, and t is basically 2 pi, because for sine function the period is 2 pi. So this will be equal to 2 times then 0 to 2 pi log of modulus of 14 sine t dt. Now we have to simply break this modulus into two parts, because we know from 0 to 2 pi sine can take both negative and positive values. So let us break this. Now this, if we break, it will become 2 outside, then 0 to pi log of, then in 0 to pi sine of t is positive, so it will become 14 sine of t dt. Then in pi to 2 pi sine of t is negative, so it will become minus 14 sine of t dt. Now our main motive will be to keep the integrand same as well as manipulate the limits. So this we can write as 2 times, then inside the bracket integral 0 to pi log of 14 sine of t dt plus, now the second integral we can use a substitution, which is pi minus t equal to theta. So it will give us minus dt equal to d theta. So here sine of pi minus t will become sine of t itself, so it will remain unchanged, and the limits will become 0 to minus pi, and then log of minus 14 sine theta, then d theta with a negative sign. So now if we omit this negative sign, the limits will get interchanged. So like this. So this integral will become 2 times, then integral 0 to pi log of 14 sine of t dt plus, now if we want to make the integrands equal, we have to simply use a substitution here, which is theta equal to minus p. So this will give us log of, this will become 14 sine of p, and then minus dp, so here a negative sign, and then the limits will be from pi to 0. Now again, if we omit this negative sign, the limits will get interchanged. So this will become this. So this is nothing but 4 times 0 to pi log of integral 14 sine t dt. Now this we can calculate easily. This will become 0 to pi, then log of 14 dt plus, this will become 0 to pi log of sine of t dt. Now the first integral we can calculate easily. It is nothing but pi log 14. Now the second integral is a very standard integral. You have to keep in mind this value. It is equal to pi log half. So it will become 4 times pi log 14 minus pi log 2. So our answer will become 4 times. Now pi log 14 we can write as pi log 2 plus pi log 7, and there is a negative pi log 2 here, so they will get cancelled. So we will be left with 4 times pi of log 7. So this will be equal to pi log 7 to the power 4, and 7 to the power 4 is 2401. So pi log 2401. That means our option D will be the correct option for this question. I hope you understood this question. This is the question number 3. Let f defined from R to R be defined as this. So f is a piecewise defined function where this square bracket denotes the greatest integer function. Then we have to tell whether fx is continuous at x equal to 0 or not. And we have to find the corresponding value of k. So okay, let us see this fx. Now we know by the definition of continuity of a function, if a function is continuous at x equal to 0, then f of 0 should be equal to limit x tending to 0 f of x. But limit x tending to 0 f of x exists only if both the limits from right hand side and left hand side are equal. So we can say that if this fx is continuous at x equal to 0, then limit x tending to 0 positive f of x should be equal to limit x tending to 0 minus f of x equal to f of 0. So we have to check whether these two are equal or not first. How to check this? Here we can see in the expression for fx there is a greatest integer function involved. And there is also a signum function. What is signum function? Signum function is a function which gives the value 1 if the number or the input is positive, and gives minus 1 as the output if the input is negative, and gives simply 0 if the input is 0. That is the signum function. Now let us check the behavior of this function inside this greatest integer function. This is x divided by tan inverse x. Okay. Now we simply can draw the graphs of this function to analyze the behavior. Let's say this is the line y equal to x, and this is the function y equal to tan inverse x. Now we can see easily for x greater than 0, x is strictly greater than tan inverse x. Now can we tell this by this graph that x is less than tan inverse x for x less than 0? No, this is wrong. How? Let us take x equal to minus 1. So x will be minus 1, so tan inverse x will be minus pi by 4. Then x divided by tan inverse x will simply become 4 upon pi. This is greater than 1. So we can say that in the neighborhood of x equal to 0, x is greater than tan inverse x. So x by tan inverse x is greater than 1, and also is less than 2, because we are just talking about the neighborhood of x equal to 0. So we can say the greatest integer of x divided by tan inverse x will be simply 1. And what is the value of signum 1? Signum of any positive number is 1. So this will be simply equal to 1. So we can say that no matter how we approach x equal to 0, from the left hand side or right hand side, the value of this signum of greatest integer will be always equal to 1. So we can say that these two limits have to be same. So limit extending to 0 f of x exists. So we can say by the definition of continuity, f of 0 should be equal to limit x tending to 0 f of x. So now we have to calculate the value of k by this equation. So f of 0 is k. It will be equal to limit x tending to 0 f of x. So we analyze the behavior of this fx for x less than 0 and x greater than 0. So this will be equal to limit x tending to 0. Then f of x we can write as tan cube x minus x cube divided by x sine square x into 1 minus cos of pi of x. Now let us calculate this limit in the next page. So here k will be equal to limit x tending to 0, then tan cube x minus x cube, and in the denominator x sine square x we can write as x cube, and then 1 minus cos pi x as it is. Now we know when t tends to 0, 1 minus cos t divided by t square is equal to half. So we can write this as 1 minus cos pi x, so we can multiply and divide by pi square x square. Now this thing can be written as half. So it will become 2 over pi square limit x tending to 0, then tan cube x minus x cube divided by this will become x to the power 5. Now how to solve this limit? We have to simply use the infinite series expansion of tan x. That means we can write this tan x as x plus x cube by 3 plus 2 by 15 x to the power 5 plus so on up to infinity. So this will become 2 by pi square outside, and then limit x tending to 0, it will become x plus x cube by 3 plus 2 by 15 x to the power 5 and so on, whole cube minus x cube divided by x to the power 5. This will be equal to 2 by pi square, then limit x tending to 0. Now we can take this x common out of this bracket. So it will become x cube, as there is a whole cube outside. So x cube times 1 plus x cube by 3 plus 2 by 15 x to the power 4. Sorry, this will be x square, and then whole cube minus x cube, and there are this remaining terms, okay, divided by x to the power 5. Now we can simply use binomial theorem here, as we know that x tends to 0, so all these terms except this one tends to 0. So we can write 1 plus x whole to the power n equal to 1 plus nx when x tends to 0. So we can write this as limit x tending to 0, and by the way there is a 2 by pi square outside, so this will become x cube, then 1 plus 3 times x square by 3 plus 3 times 2 by 15 x to the power 4 plus so on. So this will be 1 plus x square plus 2 by 5 x to the power 4 plus so on minus x cube divided by x to the power 5. Now we can see that this term and this term we get cancelled with each other, x cube term, and this x to the power 5 will give us the value 1, and all these remaining terms, those will be all equal to 0. So we don't have to bother about them. So our answer in this case will be equal to 2 by pi square. So the value of k will be 2 by pi square, which is option number C. I hope you understood this question. Let's proceed with the next question. It is question number 4. Here it says, for n greater than 1, the terms in the expansion of this are arranged in decreasing powers of x. If the first three coefficients are in an AP, then the number of terms in the expansion having integral power of x is what? Okay. So let us look at this expression first. It will be x to the power half plus x to the power minus 1 by 4 divided by 2 whole to the power n. Now here it is given that the first three coefficients are in an AP. Note this term coefficients. It is not saying about the binomial coefficients. And this expression is arranged in decreasing powers of x. That means the power of this term must increase. So the general term of this expansion, when the power of this second term is increasing, will be NCR, then x to the power half whole to the power n minus r, then x to the power minus 1 by 4 divided by 2 whole to the power r. So the coefficients of this will be NCR divided by 2 to the power r. So the first three coefficients are in an AP. That means the first three coefficients will be simply NC0 divided by 2 to the power 0. So 1, then NC1 divided by 2, then NC2 divided by 2 square. So these are in AP. That means we can write NC0 plus NC2 divided by 2 square equal to 2 times NC1 divided by 2. So this will be equal to, if we multiply by 4 both sides, so this will be 4 plus this will be n times n minus 1 divided by 2 equal to 4 times n. So here it will become n by 2 times n minus 1 will be equal to 4 times n minus 1. As n is greater than 1, so we can cancel this factor. So n comes out to be 8. Now we are asked to find the number of terms in this expression having integral power of x. Okay. So the general term of this expression will look like this: 8CR x to the power, this will be 8 minus r divided by 2 times x to the power minus r by 4 divided by 2 to the power r. This we can further simplify as 8CR, then x to the power 4 minus r divided by 2 minus r divided by 4 divided by 2 to the power r. Now from here we can directly say that if x has to have integral powers only, then r should be a multiple of 4. Now we know that in this expansion r varies from 0 to 8. So r can be 0, r can be 4, and r can be also equal to 8. These are the possible values of r. That means option A is the correct option for this question. I hope you understood this question. The next question says the value of this whole expression is equal to what? Okay. So this is a series of tan inverse with a limit n tending to infinity, and there we have to take the cot of this limit. Okay. So first let us simplify this expression one by one. Now this series we can easily solve by telescopic method. We can write this series as summation r equal to 1 to n tan inverse. Now this we know, whenever we are solving a telescopic series of a tan inverse function, we have to create a single 1 in the denominator anywhere. So let us divide both numerator and denominator by this 3 to the power 2r plus 1. So this will give us 6 to the power r divided by 3 to the power 2r plus 1, and this will become 2 by 3 whole to the power 2r plus 1 plus 1. Now in the numerator we can write this expression as 6 to the power r divided by 9 to the power r times 3. Now here is a 1 by 3 here. So we can write this 1 by 3 as 1 minus 2 by 3. Why we have to write this? Because if we observe this term, we can write this 2 by 3 whole to the power 2r plus 1 as 2 by 3 whole to the power r times 2 by 3 whole to the power r plus 1. And the difference of these two terms we have to create in the numerator. So we can write this as 1 minus 1 by 3 times this we can write simply as 2 by 3 whole to the power r. So it will become, sorry, this will be 2, and this will be equal to 2 by 3 whole to the power r minus 2 by 3 whole to the power r plus 1. So the series becomes summation tan inverse 2 by 3 whole to the power r minus 2 by 3 whole to the power r plus 1 divided by 1 plus 2 by 3 whole to the power r times 2 by 3 whole to the power r plus 1. Now we can see that this series is nothing but a simple tan inverse a minus b divided by 1 plus ab type of relation. So we can split this as summation, then tan inverse 2 by 3 whole to the power r minus tan inverse 2 by 3 whole to the power r plus 1, where r runs from 1 to n. Now if we expand this series, this will become tan inverse, this will be 2 by 3 minus tan inverse 2 by 3 whole square, then tan inverse 2 by 3 whole square minus tan inverse 2 by 3 whole cube, then so on. When we put r equal to n, it will become tan inverse 2 by 3 whole to the power n minus tan inverse 2 by 3 whole to the power n plus 1. And if we sum up all these terms, this will get cancelled. So we will be left with tan inverse 2 by 3 minus tan inverse 2 by 3 whole to the power n plus 1. So if we tend n towards infinity, this term will become simply tan inverse 0. So tan inverse 0 is 0. So this will become simply cot of, inside this cot function, it will become tan inverse 2 by 3. Now what is cot of tan inverse 2 by 3? It is simply equal to 3 divided by 2. So option B is the correct option for this question. Let us proceed with the next question. Now, the next question is from the topic functions, or specially application of derivatives in finding the increasing or decreasing nature of a function. Let f defined from 0 to pi by 2 to r and g defined in the same interval be two functions defined by this. Then the value of a for which this inequality holds true is what? Okay. So here this f of g is a function, let's say hx. So it tells that h of 1 minus a is greater than h of a square minus 1. Now how can we use this information to find the values of a? We can do that by finding the nature of this function hx, which is f of g. But first, the most important point here is to check whether both these domains are satisfied or not. That means, does 1 minus a lie in this domain of G, or a square minus 1 lies in the domain of G or not? We have to check that first. So the domain of G function is 0 to pi by 2. That means if this inequality is valid, we have to have 1 minus a is lying in the interval 0 to pi by 2. So we can say that minus a should belong to the interval minus 1 to pi by 2 minus 1, and also a should lie in the interval 1 minus pi by 2 to 1. And also this also have to be satisfied. That means a square minus 1 should lie in the interval 0 to pi by 2. So a square should lie in the interval 1 to pi by 2 plus 1. That means a should lie in the interval minus root under pi by 2 plus 1 to minus 1 union 1 to root under pi by 2 plus 1. If this inequality holds true, then a should lie in this interval and this interval also. That means the intersection of these two will be the final possible values of a. So let us check whether these two are simultaneously possible or not. Now we know that pi by 2 is nearly 1.57. So here this implies a belongs to open minus 0.57 to 1. And from here we can approximate this as 1 plus pi by 2 we can write as 2.57, and square root of 2.57 will be approximately 1.6. So here the values of a will be open minus 1.6 to minus 1 union 1 to 1.6. Now we can observe a very important thing, that the intersection of these two set of values is null set. That means a cannot simultaneously belong to this interval and this intervals. That means no value of a is possible for which the inequality given in this question is true. That means the option D will be the correct option in this case, because no value of a satisfies this inequality. So whenever you are given a question on increasing and decreasing nature of a function, always keep in mind that the domain of each of the functions has to be satisfied. Otherwise, the given inequality will not be possible for any value of the unknown. Let's say a in this case. Okay. So this thing you have to keep in mind. Let's proceed with the next question. This is the question number 7. It says, consider an ellipse, okay, centered at 5, 4, such that its major axis is parallel to the positive x-axis. Okay. So let us draw a rough diagram in this case. This is, let's say, our coordinate axis. Let me draw it a little clearer. So let's say this point is 5, 4. Okay. And its major axis is parallel to the positive x-axis. That means the ellipse is a horizontal ellipse, and the ellipse touches both the axes. Okay. That means the semi-major axis of this ellipse will be equal to 5, and the semi-minor axis of this ellipse will be equal to 4. So here this ellipse touches both the axes. This is x, this is y. Now let us read further. Let f1 and f2 be the two foci of this ellipse. So here f1 will be somewhere here and f2 is somewhere here. Let's say two straight lines both having positive slopes, okay, and passing through f1 and f2 respectively meet each other at a common point P on the ellipse. So let's say this is f1 and this is f2, and there is a point P on the ellipse such that a line from f1 and another line from f2 passes through this point P, and both of these lines have positive slopes. So the diagram will look something like this. If we draw this diagram a little bigger here, So this is the horizontal line. This is F1 and this is F2. And this is the point P on the ellipse, and this is the line PF1 and this is the line PF2. Both have positive slopes. So in this case, we can see the diagram is not correct. So let us draw it a little accurate. So the diagram will look somewhat like this. This is the point P and these are the two lines. Now here it says the bisector of the angle F1 PF2. Okay. So the angle bisector of this angle is this. Okay. So F1 PF2, this angle bisector is like this. Intersects the major axis of the ellipse at the point M. So this is the point M. If M divides the line F1 F2 internally in the ratio of 2 is to 1, then we are asked to find the distance of P and F1. Okay. So this M point divides the line F1 F2 internally in the ratio 2 is to 1. So 2 here and 1 here. This is the ratio 2 is to 1. Now we have to find this distance P and F1. So we have to find this. How can we find this? Let us have a look at this diagram and write the equation that is already known to us. What is that? Yes, you are right. As P lies on the ellipse and both of these two lines passes through the foci of this ellipse, we can write that the sum of the focal distances of this point from the foci is equal to the length of major axis of the ellipse, which is 2 times 5, so 10. So PF1 plus PF2 is equal to 10. This is our first equation. Now here are two unknowns PF1 and PF2. So we need another linear equation to solve for the values of PF1 and PF2. How can we find that? We have to consider this information that this M point divides the line F1 F2 internally in the ratio 2 is to 1. Now how to use this information? This is the critical point of this question. Now from our basic geometry, we know a theorem called internal angle bisector theorem, which states that the angle bisector of a given angle always cuts the opposite side in the ratio of the adjacent sides. That means if M point divides this F1 F2 in the ratio 2 is to 1, so we can write that PF1 divided by PF2 will be same as 2 by 1. That means PF1 will be 2 times PF2. This is the second equation that we can derive from here. So now we have two linear equations and two variables we can solve easily. So here PF1 will become simply 2 times PF2. So 2 times PF2, if we substitute in the equation 1, it will give us PF2 equal to 10 by 3. So PF1 will be 20 by 3. That means the distance of the point P from the focus F1 is equal to 20 by 3. So option B is the correct option for this question. I hope you understood this question. These basic theorems and applications of basic theorems you have to keep in mind, because sometimes JEE can test us on the basis of those concepts. The next question says that let x1, x2 and x3 be three positive real numbers such that summation xi square is 83, summation xi cube is 495 and product of xi is 105. Then we are asked to find the equation whose roots are x1, x2 and x3. Okay. So how can we determine the equation whose roots are x1, x2 and x3? We know that the equation will look like this: a times x cube minus summation xi times x square plus summation xi xj times x minus product of xi times 1 equal to 0. So we already know the value of product of xy, which is 105. So we need to determine these two unknowns. How can we determine this? By using the informations given. So let us call this summation xi equal to a and summation xi xj is equal to b. Now we know that summation xi square will be summation xi square plus 2 times summation xi xj. So here we get summation xi square is already known to us, which is 83, plus this 2 times this will be b. It is equal to a square. So this is our first equation. Now let us consider this piece of information. So we know summation xi cube minus 3 times product of xi is equal to summation xi times summation xi square minus summation xi xj. So this is known to us, which is 105, and this is also known to us, which is 495. Now we can write this as 495 minus 3 times 105, which is 15 and 3 equal to, this will be a times 83 minus b. So this, if we calculate, it will become 180 equal to a times 83 minus b. Now from these two equations we need to find the values of a and b. So how can we find? Let us put the value of b from here. So b is a square minus 83 divided by 2, and from here we get 83 minus b will be equal to 83 minus a square minus 83 whole divided by 2, which is equal to, this will be 3 times 83 minus a square divided by 2. So this will be 9, 3 8s are 24 minus a square divided by 2 times a equal to 180. So from here we get a times a square minus 249 equal to minus 360. So we get a times 249 minus a square is equal to 360. From here we get a cube minus 249a plus 360 equal to 0. Now this is a cubic equation. Let us check the nature of this cubic. So this will be, the derivative of this cubic will be 3a square minus 249. This will be 3 times a square minus 83. Now this derivative is always greater than 0. How? Because we know that a square equal to 83 plus 2b, and as b is the sum of those three real numbers taken two at a time, so b must be positive. So a square minus 83 must be positive. So that means there is a unique solution for a. Now how to find that solution? We can try by trial and error. There are no other method to solve this cubic. Let us try a case a equal to, let's say, 15. So from here we get 15 cube minus 249 times 15 plus 360 will be this. If we take the 15 common, it will be 225 minus 249. So 225 minus 249 plus 360. So this now will be equal to 24 times 15 with a negative sign plus 360. So 24 times 15 is 360 and with a negative sign. So this will give us the answer 0. That means a equal to 15 is the unique root of this cubic equation. That means we get the value of a, which is summation xi equal to 15. Now we can easily find the value of b, which is a square minus 83. So 15 square, which is 225 minus 83. So this will be equal to, divided by 2. So this will be 2 and then 1 4 divided by 2. So 71. So the cubic equation will look something like this. A times x cube minus this is 15 x square plus 71x minus 1 equal to 0. Now a can be anything other than 0 because a is the leading coefficient of this polynomial. So now if we check here, the first option is rejected. The second option is basically 2 times x cube minus 15 x square plus 70x minus something. But here it didn't match. So option B is also not correct. Let us check the third option. It is basically 3 times x cube minus 15 x square plus this is 71x minus this is 105 equal to 0. So here we, by the way, this will be 105 because this is the product of the roots. So here we get that putting the value a equal to 3, we get the C option. That means C has to be the correct option for this question. I hope you understood the question. The next question says that the total number of distinct x belong to 0 to 1 for which this equation holds true is what? So we have to find the number of solutions of this equation in the interval 0 to 1. Okay. So if we assume this function as fx equal to integral 0 to x t to the power 10 plus 1 divided by t to the power 10 plus t to the power 4 plus 1 dt minus 6x plus 5, we have to find the number of roots of fx in 0 to 1. So we have to check the nature of fx, whether this fx intersects the x-axis in this given interval or not. So let us differentiate this function. So f dash x will be this by Newton-Leibniz rule will become x to the power 10 plus 1 divided by x to the power 10 plus x to the power 4 plus 1, and this will be minus 6. Now we can actually add and subtract a plus x to the power 4 here. So this part, if we separate these two parts, it will become 1 minus x to the power 4 divided by x to the power 10 plus x to the power 4 plus 1 minus 6. So minus 5 minus x to the power 4 divided by x to the power 10 plus x to the power 4 plus 1. So we got that f dash x is less than 0 for all x belonging to this interval, because x to the power 4 divided by x to the power 10 plus x to the power 4 plus 1 is always positive or equal to 0 in this interval. So this is greater than equal to 0. That means this whole f dash x will be less than 0. That means fx is strictly decreasing function in the interval closed 0 to 1. Now what is the value of f of 0? F of 0 is basically 5. Now we have to check the value of f1 to check whether this function has a root in this interval or not. So let us check f of 1. It will be integral 0 to 1 t to the power 10 plus 1 divided by t to the power 10 plus t to the power 4 plus 1 dt minus 6 plus 5. So basically minus 1. Now we have to check whether the f1 is negative or positive. Because if f1 is positive, that means fx has no root in this interval. But if f1 is less than equal to 0, then we can say that there is at least one point x equal to some x naught in this interval such that x naught is the root of this fx. That means this equation will have then a solution in this closed interval 0 to 1. So how to find or approximate the value of f1? We have to play with this integral. So we can write that this integral, let's say this as I. So we know as x belongs to 0 to 1. Now we can write that t to the power 10 plus 1 plus t to the power 4 will be always greater than equal to t to the power 10 plus 1. Why? Because t runs from 0 to 1 and t to the power 4 is always positive. So if we divide both sides by a positive quantity which is t to the power 10 plus t to the power 4 plus 1, the inequality sign will remain unchanged. Now we can say that both the functions are positive in this interval, so we can directly compare the integral of this function from 0 to 1. So this is our integral I. So we can say that I will be less than equal to this integral. If we evaluate, this will cancel and this will integral will be 1 only. So we can say that I is less than equal to 1. That means I minus 1 will be less than equal to 0. So f of 1 less than equal to 0. So what does this tell us? It tells us that fx is a decreasing function and f of 0 is 5. And also value of fx at x equal to 1 is less than equal to 0. That means there must be a root of fx in the interval close 0 to 1. That means the total number of distinct x belong to 0 to 1 for which this equation holds true is 1. So option B will be the correct option for this question. I hope you understood this question. This is a very important concept that was explored in JEE Advanced 2016 probably. There was a question, you can attempt that question after this discussion. This question is somehow inspired from that question. Let's proceed with the next question. This is the 10th question of this mock paper. Let S be this set. Then the value of sum of all theta which belong to the set S is what? So basically, it is an trigonometric equation. We have to solve for the values of theta and then we have to sum them up. Now, how to solve this equation? Basically, there is a trick in this type of questions. Whenever we see sine theta divided by cos of 3 theta type of expressions, you have to keep in mind that this type of expressions can be converted into a telescopic series. How? We write this equation here and multiply both numerator and denominator by cos of this angle, the upper angle, which is theta. And now we multiply and divide by 2. So this gives us half times sine of 2 theta divided by cos 3 theta cos theta. Now the trick is to write this 2 theta as difference of 3 theta and theta. And then we apply the relations for compound angle. So it will become half times sine of a minus b will become sine a cos b minus cos a sine b. So sine 3 theta cos theta minus cos of 3 theta sine theta divided by cos of 3 theta cos theta. So this will be simplified to half times tan 3 theta minus tan theta. This is a telescopic relation because for all the remaining terms, this will follow the same procedure. That means we can write this expression as half will come out as common, then tan 3 theta minus tan theta, then plus tan 9 theta minus tan 3 theta plus tan of 27 theta minus tan of 9 theta equal to 0. You can see that these terms will get cancelled with each other. That means the solution we get from this equation will be the same as the solution of the equation tan of 27 theta equal to tan of theta. Now we know that the general solution of tan theta equal to tan alpha is theta equal to n pi plus alpha. That means the solution of this equation will be 27 theta equal to theta plus n pi, where n is an integer. So it becomes theta equal to n pi divided by 26, where n belongs to the set of integers. Now we are given a range for theta. From there we have to calculate the possible values of n. That means theta belongs to the interval open 0 to pi by 4. That means n pi by 26 should also belong to 0 to pi by 4. That means n should belong to the interval 0 to, this will be 13 by 2. That means the allowable values for n will be n equal to 1, 2, 3, 4, 5 and 6. So there are total 6 possible values of n. Now the corresponding values of theta will be pi by 26, 2 pi by 26 and so on up to 6 pi divided by 26. So if we are to calculate summation theta for theta belonging to this set S will be equal to pi by 26 times summation n from n equal to 1 to n equal to 6. So this will be equal to pi by 26 times, this will be 6 times 7 divided by 2. So this comes out to be 21 pi divided by 26. So the correct option for this question will be option number D, which is 21 pi by 26. I hope you understood the concept behind this type of questions. The next question, question number 11, is from system of linear equations. Okay. So for the system of linear equations, this, which of the following statements is not true? Okay. So we are given four statements in four options. We are to check whether this A option is correct or incorrect and so on. We have to tell which of the following statements is incorrect. So for any system of linear equations, we solve by Cramer's rule generally. Let us consider all the determinants. So delta, delta 1, delta 2 or delta 3. So delta will be the determinant of all the coefficients of x, y, z. It will be equal to determinant 1a1, 1b2, 173. And delta 1 will be by replacing this column of coefficients of x with 6, 3, 14. So 6, 3, 14, then 1b2, 1, 7, 3. Similarly, delta 2 you can calculate easily. It will be obtained by replacing this column by this column. So I am writing the expressions of all these determinants, which is delta comes out to be, if you calculate, 2b minus a minus 7. And delta 1, if you calculate, it comes out to be 4b plus 11. And delta 2, if you calculate, it comes out to be minus of 4a plus 50. And similarly, delta 3, if you calculate, it comes out to be minus 2a plus 8b minus 3. So we first calculate all the four determinants for this. Now we have to check the options one by one. The first option says that a equal to b equal to 7. If this happens, then the system has no solution. So A option tells us about no solution. We know for no solution, delta should be 0. And delta 1, delta 2 and delta 3 should not be equal to 0. So if A equal to B equal to 7, we can see easily that delta is 0. So this case is satisfied, and delta 1, delta 2, delta 3 is non-zero. That means the system has no solution. That means this is a correct statement. So this is not going to be the answer. We have to check other statements also. Second option says that if a equal to b and a not equal to 7, then the system has a unique solution. So if a equal to b, that means this delta we can write as a minus 7, and this delta 3 we can write as 6a minus 3. So if a not equal to 7, then the system has a unique solution. That means delta is non-zero, and we know for a unique solution, delta must be non-zero. So option B is also correct. Now option C says that there is a unique point a comma b on the line x plus 2y plus 18 equal to 0, for which the system has infinitely many solutions. So now, what are the conditions for infinitely many solutions? For infinitely many solutions, all the determinants have to be equal to 0. That means delta equal to delta 1 equal to delta 2 equal to delta 3, all must be equal to 0. Now delta 1 and delta 2, if we put them equal to 0, we get a equal to minus 50 divided by 4 and b equal to minus 11 divided by 4. So if we put the values of a and b in the delta and delta 3, we get delta is equal to 2 times b, which is minus 24, sorry, minus 22 divided by 4, minus 50 by 4, minus 7. This would be plus, by the way. So this comes out to be 28 divided by 4 minus 7, which is 0. So delta is 0 for this. And delta 3, if we check, delta 3 comes out to be 8 times b, which is minus 88 divided by 4, then minus 2a, so 100 divided by 4 minus 3, which comes out to be 12 by 4 minus 3, which is again 0. Now we have to check whether this point lies in this line or not. We check here, so it will be minus 50 by 4 minus 22 divided by 4 plus 18, which is minus 72 by 4, which is minus 18 plus 18, it is equal to 0. That means a comma b lies on this line, for which the system has infinitely many solutions. So this statement is also correct, because for this unique point on this line, all the determinants are equal to 0. That means the system has infinitely many solutions. So by the method of elimination, D option must be the incorrect option, or the option that we have to choose as the answer. Still, for learning purposes, we can check the D option. Let us check this on the next page. It says for every point on the line x minus 2y plus 7 equal to 0, the system has infinitely many solutions, except the point 7 comma 7. So we already saw that for the point 7 comma 7, that is basically the case B, the system had a unique solution. So let us take a counter example to counter this statement. We take the point, let's say 1 comma, this is 4. So let us take this point 1 comma 4. For 1 comma 4, delta is 0, but delta 1 is non-zero, delta 2 is also non-zero, and delta 3 is non-zero. That means the system has not infinitely many solutions for a comma b equal to 1 comma 4. So this statement is incorrect. So option D is the correct option for this question. I hope you understood the concept behind this question. The next question is from 3D geometry. In R cube, three lines are given as L1, L2 and L3, okay, where this lambda, mu and nu are real numbers. For which point Q among the following located on the line L2 can we find a point P on L1 and another point R on L3 such that P, Q and R are collinear. So we are to find a point Q on the line L2 such that if we pick a point, let's say P on the line L1 and R on the line L3, P, Q and R are collinear. So here let us take general points on these three lines. The general point in line L1 will look like lambda 0, 0. This is on line L1. So let's say this as P. And Q will look like this will be 0, then mu, then 1. And a general point R on the line L3 will look like 1, 1 and nu. So what is the use of this information? P, Q and R are collinear. That means PQ equal to K times PR, where K is a non-zero constant. That means PQ equal to K times PR. So if we calculate PQ vector, it will be equal to minus lambda, then mu, then 1. And similarly, PR vector will be 1 minus lambda, then 1 and then nu. Now we know that if PQ equal to K times PR, where K is non-zero, then we can write this as minus lambda divided by 1 minus lambda equal to mu divided by 1 equal to 1 minus nu equal to some constant k, which is non-zero. That means from here we can write that mu should be non-zero as well as lambda should also be non-zero. Now from these relations we can find the value of lambda. So let us find the value of lambda. This will be minus lambda equal to mu times 1 minus lambda. That means minus lambda plus mu lambda equal to mu, or lambda equal to mu divided by mu minus 1. Now we know that lambda, mu and nu are finite real numbers. So mu cannot be 1. So mu also cannot be equal to 1. And also here we can tell that lambda should not be equal to 1 and nu should not be equal to 0. So if we use these informations here in this P, Q and R, we can say that in this option A, mu is equal to 1. So this option is not possible. Now let us check the second option. Here mu is half. So basically mu cannot be 0 or 1, but mu can be half. So this option is possible. For C option, mu cannot be equal to 0. So this option is also not possible. And the D option does not even lie on the line L2. So this option is also not possible. That means option B will be the correct option for this question. A pure conceptual question based on the collinearity of 3 points on 3 different lines. Let's proceed with the next question. The next question is question number 13. Let fx be this function. Okay. So let us first expand this sigma to find the expression for fx. Fx is 1 plus this will be x plus this will be x cubed by 3 plus x to the power 5 divided by 5 plus x to the power 7 divided by 7. Then the value of double derivative of f inverse x at x equal to 1 is what? So we are given the expression for fx and we are asked to find the double derivative of the inverse function of fx at x equal to 1. Now here you need to remember a very important concept, that is the derivative, or more accurately the double derivative of inverse of a function, that is given by a direct relation. You have to remember it. But let us first derive that expression. So let us call this function f inverse x as y. So y is f inverse of x. That means fy will be equal to x. And f inverse x exists because fx is both 1 1 and onto function. Now we can write this expression as d2y divided by dx2, which is equal to d dx of dy dx. Now here is the trick. We can write this dy dx as 1 over dx dy and then differentiate this using the rule of differentiation. So this will give us minus 1 over dx dy whole square times d dx of dx divided by dy by the chain rule. Now again, we can write this using the chain rule as d dy of dx dy into dy dx. Now this expression will be nothing but d2x dy2. Now again we can write this as 1 over dx dy. So our expression for d2y upon dx2 becomes simply minus 1 over dx dy whole cube times d2x dy2. This is the relation you have to keep in mind. This is a very important relation for finding the double derivative of a inverse function. So now if we substitute y equal to f inverse x in this expression and x equal to fy also, we get d2 dx2 of f inverse x will be minus 1 over dx dy will become f dash y. So f dash y whole cube times d2x dy2 will become f double dash y. Now, if we want to find this double derivative at x equal to 1, we have to find the corresponding value of y. So, we can say that f inverse x will be equal to y. And so, if I put x equal to 1, we get y equal to f inverse of 1. That means the value of y will be f inverse 1. Now, f inverse 1 from this relation is basically 0. Because if we put x equal to 0, f of 0 will be 1. That means the corresponding value of y will be 0. So the derivative of this at x equal to 1 will be simply this expression evaluated at y equal to 0. Now we need to simply find the derivative of this function and double derivative of this function at y equal to 0. So f dash of y will be 1 plus this will be x square plus this will be x to the power 4 plus this will be x to the power 6. Sorry, this will be f dash x by the way. And double derivative of this function will be 2x plus 4x cube plus 6x to the power 5. From here, we can say that f double dash y at y equal to 0 will be equal to 0 and f dash y will be non-zero. That means the double derivative of f inverse x evaluated as x equal to 1 will be equal to 0. That means option A is the correct option for this question. I hope you understood the concept that has to be applied while solving this type of questions. The next question, which is question number 14, is from the topic of definite integration. Here it says that f is a function defined in this interval to all the real numbers is defined as fn of x equal to 1 minus x whole to the power n. Okay. Let gn be the integral of fn x whole to the power n from 0 to 1 and hn be this function. If in equal to gn divided by hn, then we are asked the sum I1 plus I2 plus I3 plus so on up to I20. Okay. So let us write this In first. So In is basically Gn by Hn, which is integral 0 to 1 fn x we can substitute from here 1 minus x to the power n whole to the power n dx divided by 0 to 1 1 minus x to the power n whole to the power, this will be n plus 1 dx. So In is basically this. We are asked to find summation In from n equal to 1 to 20. So now we can observe easily that this is the same integral format that I discussed in a recent video, which is if I of r comma n is integral 0 to 1 1 minus x to the power r whole to the power n dx, then there is a result you need to memorize, that is I of r comma n divided by I of r comma n plus 1 is equal to 1 plus 1 divided by r into n plus 1. This is the formula that we have to use here. So this integral is nothing but I of n comma n divided by I of n comma n plus 1. So I of n comes out to be 1 plus 1 divided by r equal to n, so n into n plus 1. This is the general expression for In. Now we are asked to find the sum, so we simply sum this up. Summation In from n equal to 1 to 20 will give us summation 1 from n equal to 1 to 20 plus this summation 1 over n into n plus 1 from n equal to 1 to 20. Now this we can easily evaluate. This will be equal to 20, and this term we can evaluate by telescopic series. So this we can write as 1 over n minus 1 over n plus 1, and by telescopic method it will come out to be 1 minus 1 over 21. So it becomes 21 minus 1 over 21. So this becomes 440 divided by 21. That means it is equal to P by Q. So P comes out to be 440 and Q comes out to be 21. And the value of P plus Q becomes 461. So option C is the correct option of this question. I hope you understood how to solve this type of questions. You need to remember this formula for solving these questions in a faster way. The next problem is from probability. Consider an experiment of tossing a coin repeatedly until the outcomes of two consecutive tosses are same. If the probability of a random toss resulting in head is 1 by 3, then the probability that the experiment stops with head is what? Okay. Now here the coin is biased. So probability of head will be 1 by 3. That means probability of tail will be 1 minus 1 by 3. So 2 by 3. Now we need to consider cases for this. Now we are given that the coin is tossed until two consecutive tosses are same, and also the experiment stops with a head. That means last two tosses must give us head. So we have to consider different cases for these combinations. The first combination will be HH itself. Head on first toss and then again head. So this is one of the possible combinations. Now what will be the next possible combination? It will be tail, head and head. tail in first toss, then two consecutive heads. The third combination will be head, tail, head, head. Then similarly, tail, head, head. Then it will be head, tail, head, head, and so on. It will continue to infinity. Now let us consider the probabilities of all these combinations. So the probability of this will be 1 by 3 times 1 by 3. So 1 by 9. Similarly, the probability of this will be 2 by 3 times 1 by 3 times 1 by 3. So 2 by 3 times 1 by 9. The probability of this will be 2 by 3 times 1 by 9 times 1 by 3. So 1 by 3 times 2 by 3 times 1 by 9. This will be 2 by 3 times 1 by 3 times 2 by 3 times 1 by 9. This will be 1 by 3 times 2 by 3 times 2 by 3 times 1 by 3 times 1 by 9. So if we add all of them, we will get 1 by 9 will be common, and then 1 plus 2 by 3 plus this will be 2 by 3 times 1 by 3, then 2 by 3 whole square times 1 by 3 plus 2 by 3 whole square times 1 by 3 whole square, and so on. Now how to sum up this infinite series? So here we can see, if we multiply this 2, we will get 2 by 9, and multiply 1 2 by 3 with 1 by 3 and keep the other 2 by 3 separate, we will get 2 by 9 times 2 by 3, and here also we will get 2 by 9 times this will be 2 by 9. So this series S will become 1 by 9 will be common, and then we take these terms together. So 1 plus 2 by 9 plus 2 by 9 whole square, and then similarly 2 by 9 whole cube, and so on up to infinity, and then group these terms. So basically there will be a 2 by 3 coming out as a common factor, 1 by 9 times 2 by 3, then inside the brackets 1 plus 2 by 9 plus 2 by 9 whole square plus so on up to infinity. So we will get from here 1 by 9, then plus 1 by 9 times 2 by 3, and then inside this bracket this infinite series. So this series will be S equal to 1 by 9 times 1 plus 2 by 3, which is 5 by 3. Then the sum of this infinite series will be 1 over 1 minus 2 by 9. So 1 over 7 by 9 we can write as 9 over 7. So it comes out to be 5 over 21. So the probability that was asked in the question comes out to be option B, 5 over 21. I hope you understood the concept behind this question. The next question is from the chapter of circles. The number of common tangents to the circles this and this is what? Okay. So let us call this circle C1 and this as circle C2. So let us find the centers of this circle first. So C1, the center of the circle will be 2 comma 3, and for C2 the center will be at minus 3 comma minus 9, and the radius of the circle C1 will be root under 4 plus 9 minus minus of 12, so 13 plus 12, that is 5, and radius of circle 2 will be root under 9 plus 81, that is 90, minus 26, that comes out to be 8. Now C1 C2 distance is what? C1 C2 distance is 5 square plus 12 square, that is 13. That means R1 plus R2 is equal to C1 C2. That means the circle C1 and C2 touch each other externally like this. So this is the circle C1 and this is the circle C2. This is of radius 8 and this is of radius 5. So we can see clearly there are three tangents possible to both of this circle like this. So 3 will be the correct option for this question. Let us proceed with the next question. Here it says, let trace of M denote the sum of the elements in the principal diagonal of a square matrix M. Okay, so we already know this definition. Now consider the matrix A equal to this. Okay, if determinant of A is 8 and trace of A inverse is this, then trace of adjoint of A inverse is what? So basically, we are given two equations to find these two variables. So let us first try to find this matrix by this information. Now determinant A we can calculate easily. It will be 0 lambda 1 minus 1 mu 6 then 1 5 2. So it will be, if we simplify this, minus lambda times this will be minus 2 minus 6, so minus 8 plus 1 times this will be minus 5 minus mu. So it comes out to be 8 lambda minus mu minus 5. It is equal to 8. That means 8 lambda minus mu comes out to be 30. This is our equation number 1. But for this, do we have to calculate A inverse first? No, because that will be too lengthy. So we can use the definition of A inverse. So A inverse is 1 by determinant A times adjoint of A. We can use this definition to find the value of trace of A inverse. That means if we take trace both sides, trace of A inverse will be 1 by determinant A times trace of adjoint of A. Now trace of adjoint A is what? We have to find this. We know adjoint of a matrix is transpose of the cofactor matrix of A. So the diagonal elements of A cofactor will be the same as its transpose. That means we have to simply calculate the cofactors of this diagonal elements of matrix A and then sum them up. And determinant A is already known to us, so this becomes 1 over determinant A becomes 1 over 8. This is equal to minus 23 by 8. It is given. So 8 get cancelled and this comes out to be trace of adjoint of A is equal to minus 23. Now trace of adjoint A will be what? So the cofactor of 0 will be 2 mu minus 30 with a positive sign, and all the cofactors will have a positive sign here. So we can say that trace of adjoint A will be nothing but 2 mu minus 30, then it will be minus 1, then it will be lambda is equal to minus 23. That means it becomes lambda equal to 30 minus 23 plus 1, so 7 plus 1 8 minus 2 mu. This is our second equation. Now using these two equations we have to find the value of lambda and mu. So we can find that it will be 64 minus 16 lambda minus mu, sorry, this will be mu, equal to 13. So it becomes 1 and 5 equal to 17 mu. So the value of mu comes out to be 3. And from here we can find the lambda, it will be equal to 2. So we have completely determined the matrix A. So the matrix A becomes simply, this will be 0 lambda is 2, 1, then minus 1, mu is 3, then 6, then 1, 5, 2. This is the matrix A. Now we have to find trace of adjoint of A inverse. Now again, do we have to actually find the adjoint of A inverse? No. We have to find the shortest approach to find trace of adjoint of A inverse. For this, we have to actually again use this information. How? So this relation that we used before to calculate trace of A inverse, that is trace of A inverse is equal to 1 by determinant of A times adjoint of A. Sorry, trace of adjoint of A. Now, if I take this in the left hand side, it becomes determinant A. Now, simply we have to replace A with A inverse. So, trace of adjoint of A inverse will be equal to, replacing A with A inverse will give us trace of A and then multiplied with determinant of A inverse, that is 1 over determinant of A. So, determinant A we already knew, so it becomes 1 by 8 times, and trace of A we can calculate because A matrix is known to us, which is trace of A becomes 3 plus 2, so 5. So trace of adjoint of A inverse comes out to be 5 by 8. That means option B is the correct option for this question. I hope you understood this question. The next question says that let z1 equal to this and z2 equal to this. Let z be a complex number satisfying this relation. Then we have to state which of the statements are correct. Okay. So let us plot these points first. This is x, this is y, and this is the point z2, and this is the point z1. Z1 is 4 comma 6, and this is the point 10. Sorry, this will be 4 comma 6 and this will be 10 comma 6. Okay. Now z be a complex number satisfying this. Now what does this tell us? It says if we travel from the line joining z and z2 towards the line joining z and z1, we will have an argument change of positive pi by 4. So basically z must lie somewhere here, so that if we travel from this line to this line, we will rotate by a angle of positive pi by 4. So if I draw this diagram a little bigger here, this is the point z2, this is the point z1, which is 4 comma 6 and 10 comma 6. Then z must lie somewhere here, and this angle is pi over 4. Now, statement 1 says that Z lies on a circle of radius 3 root 2 units centered at 7, 9. So, if we look carefully, we know that the angle subtended by any chord of a circle on the major arc of that circle is half the angle subtended by that same chord at the center of that circle. So, if we consider a circle that is passing through all of these 3 points, then this is the chord Z1 Z2, and Z1 Z2 subtends an angle pi by 4 on the major arc of this circle. So it must subtend an angle of pi by 2 in the center of the circle. So the center of this circle, let's say it is alpha comma beta, and the radius of this circle is r. So we have to find the radius and as well as the coordinates of the center. So we can say clearly by the geometry that alpha will be the arithmetic mean of 4 and 10. So 7. Now for beta, we can apply trigonometry here because this angle will be pi over 4. So beta minus 6 divided by, now this length is equal to 10 minus 4 divided by 2. So 3. So divided by 3 equal to 1045, that is 1. So beta comes out to be 9. That means the center is at 7 comma 9. And radius, if we calculate, this radius can be determined also by trigonometry. We can say that r divided by this 3 will be equal to cosec pi by 4, which is root 2. So r equal to 3 root 2. That means statement 1 is absolutely correct. Now we have to check statement 2. Now let us draw the diagram in this page. So this is the circle. This is the point Z2, this is the point Z1, and Z lies on this circle. Okay. So now we have to find the maximum possible value of argument of Z. Now we know we will get the maximum value of argument of Z when the line joining origin and the point Z on the circle will be tangent to this circle. So this circle is centered at 7 comma 9 with radius equal to 3 root 2. So this theta will give us the maximum value of arc Z. Now how to calculate this theta? We have to simply join the origin and the center of this circle and drop a perpendicular on the x-axis from the center. So our angle theta will be sum of these angles alpha and beta. So alpha will be simply tan inverse 9 by 7 and beta will be tan inverse, because this is a right angle triangle. So here we will use trigonometry. So this will be tan inverse 3 root 2 divided by this length of tangent. So 3 root 2 divided by L. Now L we have to calculate. L is basically root under 0 minus 7 whole square plus 0 minus 9 whole square minus 18 and under root. So this will become 49 plus 81 minus 18. It comes out to be 112 under root. So it comes out to be 3 root under 1 divided by 56, which is equal to 3 by 2 root 14 and tan inverse of this. So theta will be equal to tan inverse 9 by 7 plus tan inverse 3 by 2 root 14. So here we can also see that statement 2 is wrong. So statement 1 is correct, but statement 2 is incorrect. That means option A will be the correct option for this question. I hope you understood the concept behind this question. The next question says that the area of the smaller region bounded by the curve and the line, this is what? Okay. So this is the curve given to us. Let us try to interpret this curve. So we can write this as 9x square minus 36x. If we take the 9 common, it will be 4 times x, then 9 outside, and then we have to complete the square. So we add a plus 4 here, and as well as subtract 4 into 9, which is 36 here. Similarly, here we can take this 4 common from this 2. So this will be 4 times y square plus 4y minus, sorry, plus there will be 4 to complete the square, and we have to subtract 16 plus 16 equal to 0. So it comes out to be 9 times x minus 2 whole square plus 4 times y plus 2 whole square equal to 36. If we divide by 36, we get x minus 2 whole square divided by 2 square plus y plus 2 whole square divided by 3 square equal to 1. So this is an ellipse which is centered at 2 comma minus 2 with length of semi-major axis equal to 3 and length of semi-minor axis equal to 2. So this is a vertical ellipse because here this is less than 3. So let us draw the diagram. So this is our axis and this is the point, let's say 2 comma minus 2. Now the length of the major axis of the ellipse, or maybe I can say the semi-major axis of the ellipse, is equal to 3 and semi-minor axis equal to 2. So our ellipse will going to look something like this. This is, let's say, our ellipse. So we can mark these points. This is 2 comma minus 2. So this will be 2 comma 1 and this will be 2 comma minus 5. Similarly, this point will be 4 comma minus 2. This point will be 0 comma minus 2. So actually the axis touches this ellipse, the y-axis. Okay. Now if we closely observe this line, let's say this line is L. So L is 3x plus 2y equal to 8. This line actually passes through the points 2 comma 1 as well as 4 comma minus 2, because 6 plus 2 is 8 and then 12 minus 4 is also 8. So this line passes through these points like this. This is the line L. So the area of the region that is bounded by this line and this ellipse is this and this bigger region and this smaller region. So we have to find the area of the smaller region. That means we have to find the area of this region only. Now, how can we calculate this area? We have to simply subtract the total area of this segment of this ellipse minus area of this triangle. So the area of this segment, which is 1/4 times the total area of the ellipse, is pi times a times b, and a is 3, b is 2. So pi times 6 divided by 4 minus the area of this triangle, we can easily calculate as half times the base is 2 and the height is 3. So the area comes out to be this 2 and this 3 and this. So 3 pi by 2 minus 3. So this will be 3 by 2 times pi minus this will be 2. So 3 by 2 times pi minus 2. That is the area of the smaller region bounded by these curves. So option D will be the correct option for this question. I hope you understood this question. Let's proceed with the next question. So this is the question number 20 of this mock paper. It says the function f defined in this interval defined by this is what? So we have to classify the nature of this function, whether it is one or many one and into or onto. So we know that the function can be one when the function is either monotonously decreasing or monotonically increasing. So first we have to check the nature of the derivative of this function. So let us differentiate this. So f dash x will become e to the power this thing times derivative of this thing, which is 3 times x square minus 6x minus 9. Now this can be factorized as 3 times x square minus 2x minus 3, which is 3 times x minus 1 times x minus 3. Sorry, this will be plus 1. So 3 times x plus 1 and x minus 3. So the critical points of this function are x equal to minus 1 and x equal to 3. So if we plot by the wavy curve method, so this is 3, this is minus 1. Now here plus minus plus, so function increases then decreases and then increases. That means the function is not monotonic. So function has to be many one. So these options are eliminated. So we have to check only these two options, whether this function is into or this function is onto. So we know that a function is onto when this codomain is equal to the range of this function. So if we check the range of this function, let us check the value of this function at x equal to minus 1. So f of minus 1 is the local maximum value of this function. So the local maximum value of this function will be f of minus 1, which is e to the power minus 1 minus 3 minus 9, sorry, plus 9, then log 3 minus 5. So these cancel. So it becomes e to the power log 3, which is 3. This is the local maximum value. Now let us check this function at x equal to 3. So f of 3 will give us e to the power. So this will be e to the power log 3 times e to the power minus 32. So this is definitely less than this. Okay. Now if we try to find limit x tending to minus infinity f of x, it will be equal to e to the power minus infinity, because here this expression will tend towards minus infinity, so it will tend to 0. So the range of this function will be equal to open 0 to closed 3, and we can observe that the range of this function is equal to codomain. That means the function is onto. So option B will be the correct option for this question. I hope you understood this question.